Hey everybody, I'm Sam. This is Beyond REST, Web Services Design for Mobile. Is the audio all right? Not too loud? Okay, sounds really loud to me, but it's all right, I'll deal with it. Before I get started, just want to say to people potentially watching this in the future on video that the slides are available on GitHub. It's github.com/livefront/beyondrest. With that, I work at Livefront. I'm a software developer there. Livefront is a team of software developers and designers, and we build mobile apps for iOS and Android. I'm an iOS developer. I'm also a Rails developer on backend web services. I spend most of my time during the day working on iOS right now. Lately, it's been split about 50-50 between backend web services and iOS. Quick plug for TC Hack. We schedule these hack nights and we meet monthly. It's really informal. All skill levels are welcome. We get together basically to hack on personal projects or open source projects, eat pizza, drink beer. So the next Rails hack night is next Thursday. If it sounds like fun, check out the website, tchacknight.com. There's also a mobile hack night for iOS and Android, which is fun as well. Okay, so this is how I want to define web services for the purposes of this talk. This is obviously a really simplistic diagram. This just represents web services that have been deployed to production somewhere. You have those on a server, and somewhere there's a native app, either iOS or Android or any platform that's consuming those web services. This reflects kind of the production version, like you've released these web services and the native apps are consuming them. During development, there's a really critical piece missing, from this diagram, and that's the people that hook these two things together, which most of us in this room are probably these people. Is anyone currently doing this, like building an app that's hooking up to web services? Okay, so a good number of us. I want to focus a little bit on those people and how to kind of basically some ways we can make their job easier, our own jobs easier, and keep us all happy, because we all kind of know intrinsically if we're happy and we're enjoying working on something, we do a better job at it. As of 2014, this is science now, people. There's a really tiny link at the bottom there, so you can check out this research if you're interested. But there was actually not a whole lot of research to support this. We kind of all know this is true, but anyway, 2014, there was a study with 42 participants, which if you're kind of, I don't know if that's an inside nerd joke or if they just coincidentally had 42 people. Anyway. Okay, so here's what I'd like to cover today. Three things. First, I want to start out with a little bit of background on web services and kind of the current state of the art with web services and web APIs. Some design considerations for developers, and these meaning the developers that are using your web services that you build. The part from that first diagram that said people. And then some lessons and patterns, just lessons learned on the projects we've worked on at Livefront, and some patterns that I found interesting personally that hopefully some of you will find interesting as well. Okay, so let's start with state of the art. This isn't a talk about REST necessarily. It's not how to build web services from scratch with REST, so I'm going to kind of gloss over a lot of pretty common and well understood REST topics like resources, that type of thing. So we'll spend a little bit of time talking about REST, but really there are lots of really interesting things about REST that I'm going to skip. So if you have questions about that, feel free to ask, or there's obviously plenty of resources online. A lot of us probably already have some good familiarity with this, so why talk about it at all? There were three things that I kind of realized partly as I was preparing for this that I think really drive a lot of reasons for building things the way we build them that come directly from REST and that we base these services on REST. So first of all, for newcomers, if you're new to REST or maybe you're not a web services guru, this will be a quick, maybe too quick intro to REST, but it'll still be good to get us all on the same page. Also, I learned a lot about REST while I was working on preparing for this, and I just personally find it really interesting, and REST might not be exactly what you think it is. It's kind of an interesting topic. So here's my deplorably abridged REST review. It stands for Representational State Transfer. I'm going to just kind of gloss over this as well. I think it's important to know what this means, but we'll look at a couple examples, which I think will clarify this, but this is what the acronym means. coined by Roy Fielding in 2000. So this was actually part of his dissertation that he wrote for computer science for his PhD. His dissertation was actually about architectural styles of networking systems. And he defined the architectural style for the web as REST. So specifically, the acronym for REST comes from the style of building a networking system that made the web actually work. What makes it scalable, what makes it actually possible to build a system like the web. And I think this is a really important point, that this wasn't something that was just defined and then the web was created. This is derived from the web itself. Fielding is an early contributor to HTTP server software, as well as the original HTTP specification. So this is someone who was active for a long time in the community before writing this paper and coining this term. So there's nothing here about web services. There's nothing here about kind of really the topic of what we're talking about today. This is just what the web is. REST is really, it's a way to build something that lets you build something like the web. So I have a few quotes from Roy Fielding in this presentation. Here's one of them. REST has allowed web-based applications to scale from 100,000 requests per day in 1994 to 600 million requests per day in 1999. So I like this quote. I think these two numbers in particular are really interesting. The first one, 100,000, is really interesting because that's like an understandable number. This is like all of the traffic on the web is a number that's small enough that's kind of like, yeah, I know what 100,000 is. That's actually kind of blows my mind a little bit. And then 600 million, this is 1999, so quite a few years ago. I just like being able to put something on a graph that says everything. Like that was all traffic in 1999, and now that, 2015, YouTube alone is about 14 times what all internet traffic was in 1999. And this isn't actually YouTube, this is just videos watched on YouTube. So roughly 9 billion videos are being watched per day by you guys and by me. It's kind of crazy. So the web scales, it continues to scale. It's a proven platform. It's simple, we understand it. Scalable, ubiquitous in two ways. I think it's ubiquitous. First, it's everywhere, so it's available worldwide. It's also ubiquitous on the platforms that we work on. So it's really appealing to build web services on this platform, or the services to communicate with mobile apps, because of all these qualities. It makes it easy for us to do, and it just makes a lot of sense. So with that said, these are the qualities of the web. But there's kind of this controversy around whether something should be called a REST API or if it's just web services. And I want to dive into that controversy a little bit, because this helps kind of clarify, I think, some of the constraints we're working with when we build web services. Here's another quote from Fielding. What needs to be done to make the REST architectural style clear on the notion that hypertext is a constraint? In other words, if the engine of application state, and hence the API, is not being driven by hypertext, then it cannot be RESTful, and it cannot be a REST API, period. Is there some broken manual somewhere that needs to be fixed? I like, hey, Roy's got some attitude, which is kind of fun. So he's clearly kind of perturbed by this. Like, people are throwing around this REST term, but what we are doing, is it really REST? And the key to that is one of the worst acronyms on the planet, called HADIAS. How many people have heard of this before, or seen it before? Okay, so quite a few of you. This is something that I had seen before, but I think something that I just kind of ignored personally and felt like, I'll figure that out at some time in the future, and didn't really worry about it. I think I didn't really realize how critical it was to the stuff that I was working on for my career. So this has been a good opportunity for me to kind of dive into this a little bit. HADIAS stands for hypertext as the engine of application state. So not only is it unpronounceable, it's also kind of gibberish. Like, that to me doesn't really make any sense, at least obviously. So let's look at a couple examples, and I think can help kind of clarify what this is and why it's so important to what we do when we're building web services. So a really simple example, the NewYorkTimes.com. This is, let's just say you're on your laptop, open up a browser, pull up NewYorkTimes.com. You go to the home page, and you're presented with a web page with a series of links. And those links you can click on and go to other pages on this site. This is really, I think, a really basic kind of example of a web application, which in this case is really just a website. But it's really just a state machine. And you transition to those different states by clicking on links. And you know which states are available to you by which links are on the page when you load it. So here, hypertext is providing the engine for the application state, meaning you get hypertext and links. You can click on those links and transition to other states. Okay, so there are a few observations about that I think are really interesting. One is the client app, meaning your browser, or you personally, you don't need a manual for the newyorktimes.com. You just go there and you know what you can access because it's what you see on the page. You don't have to know anything about the structure of the newyorktimes.com. You just click on links, and the structure is kind of handled by the client and by where you click and what states you transition to. And you don't even have to know what states are available. You just know what you can get to because those links are visible when you go to the web page. Initially, when I was kind of thinking through this and putting the example together, actually, I was thinking this is great, but this really, the New York Times is kind of a special example. It's just like a read-only website. It's a collection of web pages, and we're talking about building applications. But this is really cool because this actually works for more than just read-only data. So it goes beyond just transitioning from states between web pages and static content. So here's another really simple example. Let's say you're still on New York Times and you sign up for an email newsletter. So you're on your laptop. The browser server interaction might look something like this. You get the sign up form, or you request the sign up form from the server, and the server returns you an HTML form. You fill it out, which in this case is just your email address, post it, and the server says, I got your request, and returns a 200 response. If we back up a couple steps, let's say there was a change in the requirements in the application, and now first name and last name are required in addition to email address. That's no problem here. The client doesn't care about that. The client still gets the form, presents it to you. You fill in all the new required fields, first name, last name, email address. Everything still works fine. So this is really convenient and really flexible and really powerful. So I'm going to make this slightly more complicated. This is a little contrived, but just bear with me here. For the purposes of this example, things don't, generally speaking, work like this in the real world. But now we have server 1 and server 2 in this example. And let's say you grab the form from server 1 and you post it to server 2. This is still totally fine, but if the requirements for that application change on server 2, now you got your form from server 1, which may or may not know about those requirements. So if you try to post the form, you leave first name and last name out, you get an error from server 2, and now our application's broken. It no longer works. This is pretty simple to solve, this problem, and it's a pretty well understood problem. We just need to make server 1 aware of those changes that happened on server 2. And I'm representing that here by that green circle with a C in it for coupling. So we've coupled those two servers together at this point. And now we have a more complicated kind of system. When we want to make changes, we have to make changes to both server 1 and server 2. And this, finally, brings us to kind of where we are with the current state of web services. We assume that coupling for the web clients that we're building, the native clients, and we build that into our systems. So we skip that first step of requesting the form, and we just build those requirements into our native applications. We just do the post. We don't do any getting here, generally speaking. And there's a trade-off there. The trade-off is it's not as flexible for us because we can't have any old sign-up form. We need to know the details, the requirements for making that sign-up form work. But it's much more simple for us to implement. It's much more simple for us to keep track of. We only have to worry about that one specific instance of the sign-up form. And as long as we make sure that the client knows how the server is configured, then everything's fine. And we're gonna be able to do this successfully. Obviously, this introduces some constraints that we'll talk about. Some considerations for when you're building these web services. So if you're like me, you're looking at this and you're thinking, what would Roy Fielding think about this situation? If there was only some way for us to know what Roy Fielding thinks about this. There's so much coupling on display that it should be given an X rating. That's what Roy Fielding thinks. So this is the type of thing that Hadias and that REST actually are designed to solve. That's what it's designed to prevent. We don't want this coupling between client and server. And seeing this in all of the web APIs that we call REST is, it perturbs Roy, which makes Roy say things that are good quotes for presentations. Okay, so I want to before we continue, I want to kind of point out one more thing about this, and that this is kind of a solved problem. This is solved by HTML and CSS. This is solved by other, or at least attempted to be solved by other things as well. I just wanted to note a couple of those. One is PhoneGap. PhoneGap is everybody familiar with PhoneGap? If it's like a native wrapper, so it basically lets a web application run in a native app on your phone. In this case, we're just really building a web app. We're not building web services, and we're not building a client app that consumes those web services. So this has limitations. If you've ever tried to build a PhoneGap app before, you know that it's difficult to kind of achieve native-like responsiveness and performance and look and feel. So that's not always a great solution. There's another one that is kind of the new, interesting, new hot thing, which is React. And React is a JavaScript library from Facebook. They have a version of it called React Native. And this works in a really interesting way where your phone actually runs kind of an interpreter for some React code. And your phone generates native controls based on JavaScript that you wrote that gets compiled into some intermediate language. So using a system like React, it would actually be possible, if we back up a couple slides, to build this and fill in those dotted lines and have React kind of provide these native controls and native experiences on a phone. This isn't really how React is designed, and as far as I know, it's not being used this way. It's still very new, but it's possible to kind of, we don't have to have that coupling necessarily. It's kind of I think in some ways an unsolved problem at this point. So generally what we do is we compensate. We know that that coupling exists. We kind of have experienced that in other applications that we've built, and we have some techniques and strategies to deal with that. And that's kind of something that we just work with when we build these web services. Fortunately, Sam Ruby is a kind of a well-known figure in the industry, co-chair of W3C. REST isn't an all or nothing proposition. One can gain significant value from partial adoption. So this really resonates with me. I think this makes a lot of sense. The web is great for a lot of reasons, and it's really appealing to build these types of services on top of web technologies. It doesn't mean we have to necessarily build a RESTful system, but the term REST has kind of come to mean the types of systems that we build. So we just call them RESTful, even though it makes Roy Fielding upset. So let's talk about considerations for developers. So developers here, again, mean the people who are integrating with your web services, not the people who are building your web services, just to clarify. Lots of ways we could make their jobs easy, and a lot of times it's our own jobs easier. I picked 3 to focus on, and I'll talk a little bit about why I picked these 3 things as we go. Web services must be documented, they must be consistent, and they must be testable. I'll talk about each one of these in a little more detail, but just from looking at this list, you might think, well, I've built lots of software, and this list applies to lots of other software that I've built. There's nothing special about web services that makes this list really any different, but there are a couple things that I just want to comment on that I think maybe make these more critical for web services than some other applications you might have built. The first is coupling, which we've already talked about. We have client and server coupled together. We need a way to communicate that coupling and make sure that everyone's on the same page during development, that that coupling exists. So documentation and testability are ways that we handle that. The other is permanence, and we'll talk about this a little bit more with backwards compatibility, but has anyone actually built web services before on your own web service API? So those of you that have probably have had experience with this, that when you put something in production and you put it out in the wild, you immediately have dependencies on what you built that are outside of your control, completely outside of your control. So once you add something and publish it, it can be really tricky to take that away. And so we need to compensate for that and make sure that that's part of what we're thinking about when we're doing this design. It also makes it really important to get as much right as often as possible when you're designing web services. Obviously, you want to do that with any project, but when those dependencies are outside of your control, I think sometimes the stakes are a little bit higher. So it's definitely something to be keeping in mind when we're talking about this stuff. So although these aren't completely unique and new for web services, they're definitely worth considering and thinking about as you're building and designing them. So for us at Livefront, when we're building these web services, we treat documentation like we treat any other feature. It's a developer responsibility. When someone goes in to add a new feature, they also add the documentation for that feature. If they change a feature to change the way it behaves, they change the documentation for that feature. This is just the way it's treated. It's not, there's no person who writes documentation later. It's just part of the process of building an application. Obviously, it must be up to date. For us, the way we handle this is through auto-validation. So the same way that unit tests run when we make changes and add a feature and add tests for that feature, we also auto-validate the documentation that gets generated. So if there's a failure in auto-validation, that's apparent to the developer who's working on that feature, and they correct that before they check in or push the changes for code review. That works really well for us. Some other places kind of publicize that they actually auto-generate their documentation, which, depending on the way you look at it, could be even better. If you have all your documentation in the code and it's just available in the source and can be auto-generated by some other tool, then that's really convenient and could work out really well. There are lots of tools that help with this sort of thing. readme.io is a relatively new startup that's trying to do this, where you give them access to your repo on GitHub. They look at the documentation in your source code, and they constantly keep a documentation that they provide from their servers up to date based on the source code on GitHub. Has anyone used or heard of readme.io before? Just curious. Still relatively new, but looks like a really interesting service. And this one is critical for developer happiness, and I'm sure we're all familiar with this, where you're working on something where the documentation is either non-existent or out of date, and it's just incredibly frustrating. So this one's really important. I'm not going to spend too long on this, but just 3 types of documentation I want to call out are reference, troubleshooting, and change documentation, all of which I consider critical and should be part of any kind of web services that you build. I'm not going to go through each one of these things for reference documentation, but the idea here is that it should be comprehensive. Should be a reference, I guess. There's some great examples from people who are doing this really well. Stripe is an API as a service company. They provide credit card like billing services. Their product is their API, and they have a great API. They're always kind of, I think, pushing best practices forward based on the decisions that they make. So a lot of times, like if you're working on a project, a web services project, and you're kind of wondering what decisions you should make about how to handle something, it can be helpful to see how Stripe handled it, because oftentimes they've made a good decision about it. One of their things that they do really well is their documentation, which is auto-generated and up to date, and also customized specifically for you when you're looking at it based on the current state of your account, which is kind of incredible. Instagram and GitHub also have great documentation. Troubleshooting docs are really a little bit different in that they should be available to users when they're working on your API or web services and kind of experience a problem with it. So for us, this means making sure we send as much detailed information as possible back in error messages. Other services also provide links to documentation, directly to the documentation, which is also a good thing to keep in mind as an option. This is an example of what I mean by detailed error messages. This is a response from one of our endpoints where, in this case, this is updating a user's profile. So instead of just the bottom line there, returning a validation error, we actually break down the attributes and validation failures for each attribute on the model. So the client can consume this, and then they know which fields to update and possibly change, or change to red, or somehow indicate that there was a problem with these fields. So in this case, just returning that error message would be good, but it wouldn't allow the client to kind of respond in a way that gives the best feedback to the user. And finally, just keeping up to date with a changelog. We've had good luck with just keeping a changelog that's available publicly as part of our API documentation, but an even better way to handle this, and something we've had good luck with also, is have a mailing list. What's nice about a mailing list is it pings people and gives them an email that tells them an update has happened, instead of just being a passive list that kind of gets updated over time. Okay, so let's talk about consistency. Just want to touch on a few things here. One thing that's really important is when you start building a REST API to just kind of embrace the standards that have come about over the past 7 to 10 years as REST has gained popularity. A few of those things, there's no reason to kind of reinvent the wheel. When a developer comes to work with your web services, it should be intuitive for them as much as possible. So an example of what I mean by that is to use a standard HTTP verbs when you're creating, updating, or deleting resources. Same with status codes. There's really no reason to deviate from this list. This is just part of HTTP and just the way the web works. So when you're building web services and thinking about responses to send to clients, just use the standard codes. And also provide consistent error responses. I want to illustrate difference between web applications and native mobile apps here with web services. if we're back on the laptop and post a sign-up form that has an error in it, when the server responds, it's perfectly fine for the server to give a 200 response, because if it received that request, and even if the form was invalid, the server just needs to tell the client that it received that form post successfully. So that's totally fine in that case. On a mobile app, we don't want this same situation, because this tells the mobile app that there was a problem, or tells the mobile app that it was successful, like the form was processed successfully, but the developer actually has to look at the response, kind of dive in and see if there's an error component in there, and dig that out and try to find out if there was actually an error processing this request. A better way to handle this is to just always use error codes for client responses in mobile apps. This way a developer knows if it's not a 200 or in the 200 range, then there was a problem, and they don't have to go digging in the response to find that out. So there are lots of web services that I've integrated with that kind of do the side on the left, even for mobile, and maybe a combination of the two. It's always better just to stick with the version on the left and be consistent about that. Okay, so finally for consistency, I want to talk a little bit about backwards compatibility. So the most critical thing about this, I think, is that you come up with a contract for what backwards compatibility is. This is to make sure that those coupled systems stay in sync about what the current state of the API is. So publish your contract, and it can kind of be boiled down to two things. Adding new stuff is usually totally fine, and removing stuff is not okay, because once it's out there, it's really hard to take it away. If you do that, if you remove something or make a backwards compatible change of any kind, that increments your API version. So instead of having one version of the API to maintain, now you have two, and that has various challenges on its own. So avoiding that for as long as possible is always a good thing. I'd like to use Stripe as an example for talking about backwards compatibility, because I think the way they handle it is really pretty interesting and kind of a good strategy. They consider this to be a concern of the web services themselves and not a concern of the end user. So they hide this as much as possible from the end user. If you want to override the version, you can do it, but they kind of just handle it for you in the general case. And the way they do this is by tracking when you first hit the API, they record which version of the API is the current version, and that becomes a version associated with your account on their system. And they continue to add breaking changes to their API, but they do so in the code with what they call gates, and all of those are recorded in one place in the code base in a list, which is basically a changelog, and actually is used to generate the changelog that they produce publicly. And during code execution, they just check those gates. They check to see what your current API version is. If that's something that you have access to, then the gate allows you to get that new feature or prevent that feature from breaking your existing integration. So this is really cool for lots of reasons. One primary thing I like about this is that it keeps the logic for the versioning consolidated in the code as conditional logic, the way any other conditional logic is in the code, as opposed to branching off, say V1 and V2, copying some parts of V1 over to V2 and then having two completely different systems to maintain. This is just a really good, I think, interesting approach. And it really makes code, I mean, Stripe is kind of renowned for not breaking integrations that are years old. They're still on, they have a major version of their API, which they put in the URL, and they're still on V1 of their API, but they have something like, I don't know, probably tens, possibly around 100 different versions of their API where they've added gates for new features. So they're constantly improving, constantly breaking things, but making sure simultaneously that old integrations don't break. And you can also override this. You can go into the control panel and just update to the latest version anytime if there's some feature that you want to enable. But this keeps all of that control on the developer side. Okay, and finally, APIs must be testable. So for us, well, I should start out by saying, generally speaking, if you're working on an application, you'll oftentimes have like a staging server that mirrors production, except developers can use it for development. If you're building an API as a product, you won't necessarily want to allow third parties access to your staging server, so you might have a sandbox server that looks like production or a test mode. Anecdotally, I think, to me, I'd be interested to hear what other people have seen as well, but to me, I think sandbox used to be more common. It seems like sites used to do that more frequently, but over time, there have been more kind of test modes where everything just runs on production, and you either use your test credentials or your live credentials. And test credentials just mean all of that data is just test data and doesn't affect production data. For us at Livefront, the best case scenario and where we're most efficient is when developers can run a server on their local machine. And this only works in certain scenarios. It has to be a project where we're building the backend web services and we're building the client app. But when we're in that scenario, that works really well for us. So that's the last option is always our preferred option, but not always possible. Okay. All right. So I'm going to talk about 3 different patterns that we've kind of discovered to be helpful on projects we've worked on at Livefront. Killswitch, Source of Truth, and PubSub. So the first one is Killswitch, and this, at its most basic level, this is just a way to make sure that if you introduce a breaking change to your API, you have a way to prevent old clients that would be broken by that change from accessing the API anymore. This is something that we find critical for our web services. You only really have to build one web service without this before you realize it's a really bad idea, and this should be in every web service you build. Because once you release apps to the wild, it's not infrequent that you want to add some new feature or change. You realize you made a mistake and you want to change the way something works. There's kind of no going back once you do that without this type of functionality. In its most basic form, this is just a way to force users to upgrade, because you can tell them that, hey, a new version's available, you need to go use that version, your version 1 isn't working anymore, go get version 2. Obviously this has some limitations. Primarily the limitation with this is that the new version needs to be available for users to go get so that they can upgrade. But once you have this infrastructure, you can customize it so that you can communicate with users to give them heads up about bug fixes that are coming or possibly even planned maintenance that you're working on. So a quick hypothetical situation, which has probably not occurred to any of us in this room, certainly not myself. You have an app in the App Store and you discover a bug and you start fixing it. And if you're an iOS developer in the room, your heart rate might be going up a little bit right now, because this is kind of a problematic thing for iOS developers. When end users discover this bug, you're basically trapped. You're stuck for 1 or 2 weeks. When people see a bug and it affects the way they use the app, they're more likely to leave 1-star reviews, the dreaded 1-star review, and we have, as iOS developers, no recourse for that. You just have to sit there and watch the 1-star reviews come in for your app, which can be kind of painful. But with a system like this, with a Killswitch type of infrastructure, you can just skip that 1 to 2 weeks and make sure that you alert people, which is not great, but much better than just being able to do nothing. For iOS developers, this is something I learned about the Google Play Store. I'm not an Android developer, but Google Play Store allows you to actually respond to customer reviews, which is kind of cool. So there is some recourse if you're an Android developer, plus you don't have to, at least currently, you don't have to suffer through kind of the App Store review wait. Although I think Google is adding a review. Is that correct? I don't know if anyone knows the latest on that, but I think they're kind of adding that into the workflow. So for us, this is technically this is how Killswitch works. We have a user agent string, and the user agent string is required for all clients that access the web service, and from this we can parse out the app version, platform, OS version, and device. So if we know about a bug specific to the Galaxy S6, for example, we can customize messaging to just reach those users. So with this set of information, it's relatively flexible, and we can kind of control that messaging. Okay, source of truth. Server is always the source of truth, except when the server is not the source of truth, which can be frequent depending on your app. One place that it happens all the time is when a client app creates a resource. The client has information that the server doesn't know about. There's also potential that you're building an app that needs to work offline. So it's important to be thinking about who's in control of what the current state of that resource is and how that affects your application. So this is an app, a screenshot from an app that some of us at Livefront are working on. The idea here is that you're in a stadium at a live sporting event, and it's a social networking app for everyone that's at that sporting event. You can take photos and post new information, and everyone has a stream where they can see these results just coming in real time. I want to focus on this thumbs up button here for an example. So you obviously love this photo of these really enthusiastic kids, and you're going to thumbs up this photo. When you do that, a really basic kind of example of how this might look on the app is to post a like to the server and then receive a 201 created response after the like has been received and registered by the server. In practice, it doesn't really work like that for us because one of the main features of this app is real-time updates. So we're constantly getting updates from the server about new information that's available. And so what this might look like in practice is we get an update from the server, we post a like for that photo, and before we get a response from the server, we might get more information about an update. And this update could be about that photo that we just thumbsed up. In fact, the change could include other likes from other users that we don't know about. And so now the app has a conflict that it has to deal with. It has to kind of gracefully handle this situation where the information coming from the server is not in sync with what it has locally. And the app knows about this. It just needs to be able to handle it. Eventually, server sends back the 201 created response, and now the app is no longer in an inconsistent state. So these problems are tricky, and this is a really simple example, but this type of thing kind of comes up frequently. So a good rule of thumb for us when we're working on these is to minimize the time that modified resource state is stored on the client. This kind of eliminates that problem as much as possible and turns these cases into edge cases instead of just the common case. Depending on the app that you're working on, that might not always be possible. If your app is specifically designed to work offline and allow the user to do things while they're offline, say in airplane mode, and then come back online and sync everything up with the server, that introduces a lot of complexity. If you've ever had to work on a system like that, you know immediately that this is something that is not straightforward, comes with lots of kind of edge cases and complexities. So it's always better to keep it simple when you can. When you have control over this, possibly even eliminating offline mode altogether is not necessarily a bad option, and it's something that we do when we can. I think it helps to look at kind of examples of high-profile apps in the wild and just see how they handle this type of thing. One example is Instagram. This is Instagram in airplane mode. Most of the interface looks like this. You just can't really do anything. It does keep a cache of some photos that are in kind of your main stream or timeline. And you can actually go through the process of selecting a photo and editing it and adding the filters and all that. But as soon as you try to click save, you just get this failed notification. And it doesn't try to do anything else on the client until you get your internet connection back. You can click that refresh button and then try to post it again. You can actually try to also like things, but when you do that, you get this kind of flicker of the like heart turning on, and then it immediately turns back off when it realizes you don't have an internet connection. So for Instagram, they really don't have much of an offline mode. They're just kind of making sure that the server is always the source of truth, and keeping as little state as possible within reason on the client. All right, final pattern, PubSub. So PubSub is just a general kind of software engineering pattern that you can use on lots of different systems. The concept, which a lot of you are probably familiar with, is that you have publishers that need to produce some kind of a notification and subscribers that need to receive it. And in between those two, you have channels that kind of take that notification from publishers and send it to subscribers or allow subscribers to get it. The key kind of insight here is that publishers and subscribers are completely decoupled with respect to the message being passed back and forth. So they don't know about each other. Publishers don't know about subscribers, or if there even are any subscribers. Subscribers don't know anything about publishers. So I want to go back to this app here to kind of talk about how we're using this in this particular scenario. Like I said before, one of the big features of this app is that it's all real-time information. So those updates are coming in real time. And occasionally maybe the user thumbs ups something, whatever they do, they like it. And that's kind of just in between lots of requests for the most recent data. And if we add another client to this picture, you can see that overwhelmingly, really, we're talking about a system that just sends updates. That's what this does. Occasionally, you might get some new data, but really, it's about sending real-time information. So this is an architecture without PubSub. If we add PubSub to this, things look a little bit different. The client still posts a like, and the server then forwards that information onto a channel. And at this point, the channel kind of takes over and does everything. Sometimes it's called a broker, but there's some process there that's running and then broadcasts this message out to the subscribers. What's nice about this is that this is just one subscriber, but this can be scaled basically infinitely. We don't, at this point, the server doesn't have to do any more work to send this message to multiple clients. All of that is offloaded to some other system that's handling this. And so this works with basically any number of subscribers. Two things to notice in this diagram. One is that the publisher only sends that update once, so its work is pretty minimal. The other is that subscribers don't know anything about publishers here, and publishers don't know anything about subscribers. So it helps us build a system that looks from the client's perspective a little bit more like this, where the server is still handling the thumbs upping, and all of the updates have been offloaded now to the subscriber. So this allows us on the server side to support far more clients with the same server resources. Okay, so that's it. A quick recap. Talked about some lessons learned and tips for web services as we've kind of been working on them at Livefront, and also the importance of developer experience. In particular, keeping consistent, up-to-date documentation is critical, and making sure that you keep developers happy is also critical. And also talked about web API state-of-the-art, and hopefully you found that kind of REST review interesting. I know this is stuff that really has defined my career, and I learned a lot kind of doing prep for this talk, especially about REST, so definitely enjoyed that and thought it was really cool. So thanks. I think we still have quite a bit of time. Yeah, questions? Sure. Yeah, that's a great question. There are lots of options out there. We have never rolled our own service. Sorry, the question was, what PubSub services do you use, and do we roll our own? The two we have some experience with are RabbitMQ, and Amazon actually can do PubSub with AWS if you use simple queue service and simple notification service. You can kind of hook those two together to get PubSub working. As far as which one I would recommend, I think I'm not really in a position to recommend one over the other. I think what we found is that all of those systems have their own strengths and weaknesses, and it kind of depends on what you're building. But have you used any, just out of curiosity? Are there any that?
A little bit of RabbitMQ. Been looking at what Azure offers for that kind of stuff.
Okay, interesting.
Partial to Azure. So.
Okay. So Azure has a PubSub kind of.
Specifically PubSub, they have two different queuing systems, and they each have their strengths and weaknesses. So.
Cool. Yeah.
We use ActiveMQ in production.
Okay, ActiveMQ.
Question on that. I'm a little confused on this, but I don't see what PubSub could do that you couldn't accomplish with simply using a cache.
Okay, so the question was, what does PubSub do that you couldn't accomplish using a cache? Is there a particular diagram that helps for discussing this one?
I think the one you're on with everyone getting it from there, that if you manage channel simply being you update the cache out at the server, accomplish the same thing, and everyone can just get from the cache.
Yep, yeah, that's a great point. This could be handled via caching as well. One of the nice things about PubSub that's a little bit possibly an advantage over caching is that the channel or the broker that's handling fanning out these messages can actually customize these messages for the subscribers. So there might be information, for example, for a message that I receive from a friend who's at an event that would be different than the message you would receive on your channel. And caching works really well when all of that information is exactly the same and I want the same notification that you want. PubSub might arguably work better if that information is customized. That introduces complexity, though. That introduces complexity to the channel to kind of handle that background process.
One also tends to be more observational, whereas the other one tends to be more request-based. The cache, it's like you're requesting, and with something like this, it's an observation pattern, or an observable pattern.
Other questions? Yeah.
Yeah, just a comment on that one, right? So very specific to that one. We use distributed memory, right, here at Best Buy, so for handling those ones, any of those type of calls, rather than the PubSub as such, right? So we use the distributed memcache.
Yep. Yeah. So yeah, another comment about using distributed memcache, basically a distributed cache to solve that same problem. Okay. Other questions? Sure.
Well, I feel like for mobile apps, a lot of times, you have like a web view, you'll need information about a couple of different APIs, and there's kind of I feel like a tendency to kind of break REST and build an API just for that web view for performance reasons. I'm just curious if that's something you've encountered and how you can handle
That's a good question. So the question was, sometimes you need to access data from multiple APIs.
Yeah, like let's say, you know, you're talking about, you had an example there that had a message with some likes and, you know, message and stuff like that. And let's say that to get the likes and to get the message content were two separate APIs.
Mm-hmm.
So the mobile app would actually have to call two APIs to show that view. But you have the option of creating a custom non-REST API just for that view. That for performance reasons, that would
Right.
make it.
Yeah, that's a good question. So just to repeat that really quick, if two parts of what the client was looking at, so maybe the likes and comments, for example, are coming from two different APIs, the client's going to have to make two requests for that information. But you could build something, some kind of service that basically does that for the client and only forces the client to make one request, and possibly do that in a non-REST-like fashion. Yeah, that's a good question. I would say, I think personally my initial response would be to try to avoid that if possible. It really depends on the application though. If this is something that's going to make a significant impact for the client and is something that's going to allow you to build a better solution, then I don't think there's any problem with that. It seems like it is adding some complexity though that may potentially be unnecessary. I don't know, I feel like that's not a great answer, but I can't think of a specific example where I've had to deal with that particular scenario.
What part of that includes break rest? Annotating two requests, like on the server.
Well, say you need two different resources, right? You need information from two different resources. And so typically with REST, it's a one resource per endpoint. That's one of the constraints. And so if you want to get information about two different resources, with REST you typically call two different endpoints to get those, which is two web calls, which is more expensive, you know, performance-wise and battery life-wise for the mobile client.
Yeah, I wouldn't see it as a direct violation of REST if you have aggregation between endpoints in one entity. In the mobile apps, built on your request, because one of them could fail,
Right.
one might not fail. It's better to aggregate those on the server as much as possible. You can have an aggregator that happens to be another client that's watching for those two resources, and they'll make another one, and that's the one your client might be looking for. Do that too.
I was just going to say, this is where linked data, I mean, this is where like hypermedia APIs are interesting in this case. Like you can have linked data and expose it via multiple endpoints, or like a single hypertext cache pattern thing where data is nested inside of it. What's with?
Just interested in the version management you mentioned, saying that they do a kind of if-else condition. Doesn't that impact the performance of the web services? Or
Yeah, that's a good question. So the question was, when we were talking about Stripe's gates for the way they handle version management, does that impact performance of those systems? That's a great question. I don't know. I've never built a versioning system like that. I just think that Stripe is a really interesting example of that kind of concept. Our versioning at Livefront has always been URL based, so we just have v1 in the URL, and then if we make a breaking change, we add v2. Fortunately for us, we've only had to do that once, and it's not a situation for us where we had to discontinue API v1. So my personal experience with that is more limited than Stripe's, but I would assume yes. I think there's definitely factors there that they have to account for performance. All right. Thanks, everybody.